Hey everybody, welcome back to another fun and exciting algebra class. Today we'll be finishing up finally, right? Chapter number 11. You've only got one more chapter after this, so keep working hard. We're going to be talking today, we're going to start on page 446. 446, we're going to be talking about proportions. What is a proportion and how do you use proportions? All right, so if you look down there at page 446, it uses the definition for proportion. It says it's a statement that two ratios are equal. Basically, you're saying two fractions are equal. This fraction equals this other fraction. One of the most important things about proportions is that you keep the same things together. Like, for example, you keep days with days. You keep time with time, years with years. You keep miles with miles. You keep feet with feet. Okay. And you'll see what I mean by that in just a second. But let's take a look at one of these. Go ahead and look down here at the screen. I'm going to start you off with a simple one. I'm going to say I have 1/2. Okay. And we want to make a proportion. This is a ratio. Okay. You say, no, it's a fraction. Fractions are ratios. Ratios are fractions. Okay. So if I have the fraction or the ratio of 1/2, I want to create something that is equal to it, okay? That's a proportion. So the way that I would do that is I would say, okay, it's the same thing as 2/4. 1/2 equals 2/4. How do I know that? Well, I know that, hopefully you remember this, from this is the extremes equal the means. So that's how you check a proportion. 1 times 4 equals 2 times 2. 1 times 4 is 4. 2 times 2 is 4. When these two things are equal to each other, that means that the fractions are definitely equal to each other, so you do have a proportion. In proportion, the means always equal the extremes when you multiply them, okay? Now, what I was saying just a second ago about making sure that you keep the days with days, miles with miles is very important. So if you have a question that says, 14 days it took the person, to walk, I don't know, how long can you walk in 14 days? Let's say 200 miles. Can you imagine living back in the Bible times, right, where you had to walk for 14 days? But yeah, think about what Mary and Joseph had to do on the way to Bethlehem, right? They had to walk forever. They didn't just jump in the car and go down there. But now we just jump in the car. We don't even think about walking. And then in the next part, maybe we have the question goes on to say, how many miles could you walk in 18 days? Well, what I'm saying about this, when you have a question like this, when you build your proportions, you're going to keep your days with your days and your miles with your miles. Watch. So we'd go 14/18 because those are days and days. And that's going to equal 200 miles over X. That's our missing miles. So I have, this is my days and this is my miles. Okay. Another way that you could do that same problem by keeping days with days and miles with miles is you could do this. 14, there's days, and 18. Now, this goes together, so you have 200, and you'd have your X here. So look, now I have my days with my days. Both my days are numerators in this case. And then here I would have my miles with my miles here. But one thing that you cannot do, this is a big no-no in proportions. This will give you the wrong answer, is if you start mixing things up and you say 14/200 equals X over 18. That's a no-no. You cannot put the days. Days cannot go across from each other. Days has to stay as numerator, or days has to stay in the same fraction. This is wrong. Days cannot be across from each other. You cannot make one the numerator of a fraction and one the denominator of the other fraction. All right, let's look at this sample problem here from your book. Amber made 2 kinds of cookies. I love cookies. Do you love cookies? I love cookies. My favorite are chocolate chip. I don't know what your favorite are, but I love chocolate chip cookies. I really love all cookies, but chocolate chip, if you're going to make me some, send them to me. Send me chocolate chip. Okay, I love them. But Amber made two kinds of cookies for her grandmother. The ratio, right? That's an important word. What does that mean? Fraction. Okay, so we're thinking fraction when we hear the word ratio of peanut butter to oatmeal raisin. You know, I don't love oatmeal raisin. They're okay. I can eat them. Like I said, I love all cookies, right? I don't discriminate against any cookies, but I do like peanut butter, especially the ones with the recent. I'm sorry. I'm hungry right now. What can I say? Some of you are like, I'm hungry too now. So some of you are going to the look for cookies right now, but come back, do math, okay? So peanut butter cookies to oatmeal raisin was 3 to 4. If Amber gave 35 cookies to her grandmother, how many of each type did she give? Okay, so how are we going to do this? All right, remember what I said just a second ago. We're keeping miles with miles, feet with feet, inches with inches. Here, we're going to keep cookies with cookies. I love it, right? We're going to keep peanut butter with peanut butter, and we're going to keep oatmeal raisin with oatmeal raisin. What do I mean? So here we go. Let's do 3 out of 4. Right here it says 3 to 4. We're what? Peanut butter to oatmeal raisin. So what does peanut butter go with? Peanut butter goes with the 3. Okay? So I'm just going to go here. I'm going to write PB. That's the 3 over OR, oatmeal raisin. So the PB is the 3. Oatmeal raisin is the 4. Why did I write this? I wrote this just for reference so that I don't mess up, so that I don't mix anything up. And that's going to equal what? Well, we're trying to figure this out, right? We're trying to figure out the 35. Let's just, we can do it either way that you want to, but let's just say that the peanut butter is the X, all right? So we'll call peanut butter the X. And we'll call oatmeal raisin what? Well, we had 35 total. So if we take 35 total and we subtract the peanut butter, that will give us the oatmeal raisin. So oatmeal raisin is going to be 35 minus X. Okay? Don't do X minus 35. That's not going to work for you, okay? You got to do 35, the total, minus the peanut butter. Okay? And so this is our fraction, believe it or not. This is what we're looking at right here. This is our proportion. How are we going to solve this? Remember what I said. What we do is we take this, the means, multiply them by the extremes. So we're going to take 4 times x equals, and then we'll do this one, 3 times 35 minus x. And there we go. There is our equation, finally, and now we can solve it. 4 times x is 4x equals, we have to distribute this one. So 3 times 35 is going to give us 105. 105. Minus 3 times x is 3x. Okay? Now you just move the things to the other side. Let's move this 3x to the other side plus 3x. That's going to give us 7x equals 105. That cancels out. And then we would just divide both sides by 7, and we get that x equals what? If you don't know that one, then just come over here. 105 divided by 7. That goes 1 time. 7, 35. 7 into 35 goes 5 times. So x equals 15. Now, you got to ask yourself the question, what was x? Go back and look at it. X was peanut butter. That's one of the reasons why we keep them together, is so that we know what they are when we're done. So, peanut butter, and I'm going to change this from x to peanut butter. PB equals 15. How do we find our oatmeal raisin? We take our 15, we take it and we plug it into this. 35 minus 15 equals, we had 20 oatmeal raisin. Okay, so there's your solution. 20 oatmeal raisin and 15 peanut butter. add those up, and you get back to your 35, and then you could plug these in. Here's a way that you could check this one, right? Because remember, our fraction, our ratio is 3 to 4. So if we do 3 over 4 equals, remember peanut butter was on top, so that would be 15 over oatmeal raisin was 20. The question is that equal? Does that work? One way that you could do it is just reduce this by 5. Reduce this each by 5, and that comes up 5 goes into 15 3 times, 5 goes into 24 times. Yes, that does work. The other way that you could do that is just solve it as a proportion again, right? So 3 times 20 equals 4 times 15. Does that work? Well, 3 times 20 gives me 60. 4 times 15 also gives me 60. So that does work both ways there. So you could solve these questions as proportions, and by making sure, don't forget that you always keep the miles with miles, feet with feet. Always keep it. I like to keep it like as the numerator. You can keep it as the fraction, but that gets a little bit distracting sometimes because then it's kind of hard to remember. But if you always keep like peanut butter as always the numerator, miles, always the numerator. It's always going to stay the numerator, whatever it is. And that will help you to work through the problem so that you don't get confused as you're going through it. As soon as you start swapping stuff, you had it as the numerator, now it's the denominator, you're gonna get the wrong answer. So keep the miles with miles, feet with feet, peanut butter cookies with peanut butter cookies. Okay? All right, well, that's all I have for you in this lesson. A little bit of a short lesson for you, right? You like that every once in a while. Watch that again if you missed anything. Try to practice some of these. Go back, find one of these practice problems. You can watch the video as you're going through it, and that hopefully will help you to get them in the right order and get them lined up and get the correct answer. Okay? That's all I got for you. Have a good one. Bye-bye.